Hi, everybody. By special request, I'm going to be doing some solutions for page 10 and 11 in the workbook, chapter 5. So let's get started right away. I'm going to move quickly so that we don't have to have such a long video. So remember, when we're solving a polynomial equation or a quadratic equation, we have to bring everything to the same side and make it equal to 0. So we're going to start off right away with one that's involving a complex trinomial. So I'm going to take the 6, and bring it over to the other side of the equation where it's going to wind up as a negative 6. Remember that any time that we bring something across the equal sign is going to be opposite signed. We try to keep those equal signs lined up if we can. And so that's going to be 0 now on the other side. There's nothing there. So we have to factor this complex trinomial. So the factors of 7, we write out backwards and forwards on this side. The factors of 6, we're going to write on the other side. And we're looking for the pair that's going to subtract to give 19. And we look at their products. So jumping to the chase here, it's going to be the 7 times the 3, which multiply to give 21, and the 1 times the 2 that multiplies to give 19. So it's a matter of just factoring complex trinomials, which hopefully everybody is getting a little bit more comfortable with. The 7 and the 2 on the first row go into the first bracket. The 1 and the 3 go into the next bracket, x and x. And to determine the signs, we look at the OI of FOIL, the inside and outside multiplications. So that's going to be 2x on the inside and 21x on the outside. So the 21 is going to have to be positive because we have to obtain a positive 19 when we put those two together. So the sign for the inside goes on the first bracket, the negative, and the sign for the second one goes on the second bracket. Now I'm going to erase this because now we have to solve for the values in the brackets. You have to say what value of x is going to make that bracket 0, what value of x is going to make that bracket 0. Well, I'm going to do the second one first because it's easier. You just have to say, well, x would have to be negative 3, and that will cause the bracket to be 0. And the other bracket, and we write an or in between, is a little more complicated, but it's going to be the solution of 7x minus 2 equals to 0, which the shortcut is that it's going to be the opposite of the constant, so the negative 2, the opposite of that is going to be positive 2, over the coefficient of x. So there are your two answers. That was a complex trinomial, takes a little more work. Question 2 is a same kind of deal. I'm going to bring everything to the left-hand side. You always want to bring everything to the side where it's going to be, where the leading coefficient term is going to be positive. So I'm also going to, at the same time, put this in an order that we're used to with the descending order of exponents. So I'm going to put the 4x from the other side next, so it's leaving 0 there, and the minus 6 stays on the left. Now, hopefully you recognize that this is a simple trinomial after you take out the GCF, making it x squared minus 2x minus 3. Otherwise, you'll be treating it like a complex trinomial, and that would be a lot more work. And so because it's a simple trinomial, we have no choice but to put the x in the x, and we only have to look at the factors of 3 that will subtract to give me a 2. So 3 only breaks up one way, 3 and 1. And the larger of the two numbers is going to take that sign on the 2, well, there, the negative on the 3 and the plus 1. Now, there are 3 factors here, the 2, the x minus 3, and the x plus 1. And any of those factors may cause this product to wind up equal to 0. So, like we did before, the x could be equal to the opposite of 1, negative 1. The x could be equal to the opposite of negative 3, which is positive 3. And you say, is there a solution for this 2? Well, 2 is always going to be 2. It's never going to equal 0. So we only have those other 2 answers, okay, that will work. Moving on to question 3. So, by the way, the first one was complex trinomial. The second one was simple. And this one, as you're going to find out, is simply going to be a GCF. I'm going to keep the 2x squared on the side where it's positive and bring the 4x over the equal sign and leaving 0. And I'm going to take out a GCF because there's only 2 terms. And remember, if there's 2 terms, you say it might be a difference of 2 squares, or it might just be GCF. But either way, you always look for the GCF first. So I'm going to take out the 2x, leaving me with x minus 2, And my two values that I'm going to get is that the x minus 2 is going to be equal to 0. So that means the x could equal to 2. Or the 2x might be equal to 0. Now, a common mistake is to think that the x could be a negative 2. But remember, these are multiplied. And so the only thing you multiply x by, 2 by, to get 0 is that the x is equal to 0 for our two solutions. You also might be noticing that I'm kind of ignoring that equals 0 at the end of each of these questions because all I really need to know is what make each of those factors equal 0. Okay, I'm going to speed up number 4 a little bit because this is just already on the same side, so life is a little bit simpler. I got to get the factors of 12 that I'll subtract to get 11, so that's 12 and 1. And the bigger one gets the negative sign. And your values, x equals 12 and x equals negative 1. Let's put a box around the answer. Moving on to the next bunch of 4 here. I'll leave that up on the screen so you can still see it. So in this case, I've got that negative x squared term, and I don't want that to be negative. So instead of keeping that on this side, I'm going to move everything to the other side and leave nothing on the left, so it's going to be a 0. So the x squared is going to become positive on the other side. The 6x is going to become negative, and the 9 is going to stay positive. And you might notice, like I said, you bring it to the side where it's going to be positive, and you put it in the proper order so that we're used to it for factoring. And then this factors with x, and the two numbers that multiply to give 9 and add to give 6 are 3 and 3, and they're both going to be negatives. Now, there's a unique situation here because the answer to the first bracket, the answer to the first bracket is 3, and the answer to the second bracket is 3. So we don't actually have to list both of them, okay? Generally, we'll just say, oh, x equals 3. Question 6, two terms. I got to bring them to the same side. And I see that the 3x squared is already positive. So I'm going to keep it on this side and bring the 6x over where it becomes opposite. And I divide out the GCF. So hopefully you're getting the hang of this. We kind of saw this in the previous question in number 3. We're going to get a factor from the bracket, which is positive 2. That's one of our solutions. And the answer for 3 times x is that x could equal 0. Now remember, we keep both of our answers in these examples. We may have to throw one of them out when it becomes an application question. Question 7, same deal. Let's go through this a little bit. Recognizing two terms, it may be a difference of 2 squares, but after you take out the 12x, you're not going to have any more exponent of 2 there. It's just going to be x minus 3. And your two solutions is that x is going to be equal to 0. X is going to be 3 here, or x is going to be equal to 0 there. Now, number 8, negative x squared. Like I said before, we do not want to have a negative, so we're going to bring everything over to the other side. X wins. The x squared term wins. It's going to be positive on the other side. The 8x is going to get dragged over there and become negative 8x, and the 16 stays positive. And we have a situation similar to what we got in question 5, because after I factor this, both values are x is equal to 4. So I'm just going to put one of them as my solution. Number 9 is a simple trinomial, so a little bit faster on this one. X and x, 3 and 4, and they're both going to be negatives. The signs are the same, okay, because they have to multiply to give a positive 12, and they're both going to be negatives so that I can get a negative 7. X is equal to 3, or x is equal to 4. Question 10, two terms. All right, is there a GCF? No, there's not. Okay, so then we have to go to the next possibility, which is it is a difference of 2 squares. You can square root 16x squared, you can square root 81, and it is a subtraction, and it's 2 terms. So the square root of 16 is 4x. 16x squared is 4x. The square root of negative 81, no, don't look at the negative, just the 81 is 9. And when we do a difference of 2 squares, it's a plus and a minus. And the reason that this ends up working is that if you were to multiply the inside and outside multiplications, they're going to cancel out. Now my two solutions, the opposite of the constant over the coefficient. In other words, this positive 9, on the top of the fraction, I'm going to put the opposite of 9 over the coefficient of x, which is 4. And for the second bracket, it's going to be the opposite of negative 9, which is positive 9, over the coefficient, which is also 4. So I get my two solutions, and they're opposites of each other. Number 11 is similar, so I'm going to speed up this a little bit. X plus 11, x minus 11, and my two solutions are x is equal to negative 11 for the first bracket, or x is equal to positive 11 for the second bracket. Now, number 12, this is kind of complicated, and it can be done as a difference of two squares. However, not a lot of students are going to recognize that, so I'm going to take the long way around on this. And the idea is you need to expand, bring everything to the same side, which they already are, so that's not a problem. And then you're going to have to factor. So, right, let me simplify first, and then you're going to factor. So in this case, I'm going to expand x plus 4 times x plus 4. And you should be pretty quick at this now, hopefully, is going to be x squared plus 4x is 8x plus 16 minus 100 is equal to 0. And this is going to simplify 8x squared plus 8x minus 84 equals 0. And in case you haven't been noticing, all right, I've been trying to keep these equal signs kind of lined up in all of these examples. I need factors of 84 that are going to subtract to give 8. And that's going to be 12. And you're not always going to guess this right away, right? So what you have to do is you have to make a list. So 1 times 84, that's no good. 2 times 42, no good. 3 times 28. 4 times 21. 5 doesn't go. 6 goes a little bit differently, but it's going to be 6 times 14. And I'm looking for the pair that subtracts to give 8, and hopefully you recognize it there. But if you didn't, the next possibility is 7 times 12. And you'll know you're done because these guys come so close together and then they don't break down anymore, right? So 6 and 14 is the pair that works, x and x. And I'm going to go, I always like to write the bigger one first because then it always matches that sign. So it's a positive 14 and a negative 6. And your two solutions will be x equals negative 14, x equals positive 6. All right, I'm going to be doing page 10 in a couple of seconds. But just to say, those are your solutions for page 10 in the workbook. Thanks, and hopefully this is going to be useful to you.